Okay, welcome back. This is chemistry question 46 from IMAT 2015 past paper. So I'll be solving this question with all explanation. So it says 2,2-dimethyl propane is an isomer of pentane. So we are given with this structural formula for each of these compounds, the isomers. And it says pentane has boiling point of 36 degrees Celsius, while the boiling point of 2,2-dimethyl propane is 10 degrees Celsius. Which statement below explains the difference in boiling point for these two substances? So before we go through each of these options, we must draw some workings so that it will make it easier to solve this question and to explain the difference in boiling points. So first of all, we know that they are isomers of each other. So again, we must recall the definition of isomer. So isomer is a compound which share the same molecular formula, but they differ in structural arrangement. So like one can be branched or one can be linear and whatsoever, but sh- they share the same molecular formula, which is the number of carbons and hydrogens and whatever elements. So we know it's purely hydrocarbon and as it has two main elements, carbon and hydrogen only. So it's mainly hydrocarbon, so we're going to only focus on number of carbons and hydrogens, and they're going to be same, but they have different structural arrangement. So first of all, we have to know the molecular formula of isomer. So we're given with the structural formula, so we can add the number of hydrogens and the carbons, so that this simplifies to give us 5 carbons and 12 hydrogens. So this is the molecular formula of the isomer. Alright, so now we know the molecular formula of isomer. Now we can go to step 2, which is the displayed diagram of isomers. So I'm going to draw the display diagram of these two different isomers so that we can clearly picture the difference in structural arrangement of these two compounds while they share the same molecular formula. So the display diagram. So first of all, it's going to be 2,2-dimethyl propane. So the center carbon is completely surrounded by methyl groups all the four sides. So this is all the methyl groups. So this is the diagram for 2,2-dimethyl propane. And now the second structure that we have, the isomer, is pentane. So this is the display diagram. And so the structure is pentane. So now we've drawn the display diagram of these two isomers. So now what we can conclude by observing these structures of these two different isomers is that this 2,2-dimethyl propane is more branched alkane and pentane is more linear structure. So we know both are alkenes and hydrocarbon, but the different structural arrangement. So this first one is the more branched structure and the second one is more linear structure. So this is the different structural arrangement and both has the same molecular formula C₅H₁₂. So now we can explain the difference in boiling point for these two substances. So now we can go through each options to explain the difference in the boiling points. So the first option says 2,2-dimethylpropane has stronger intermolecular forces. So now we must know also that both are hydrocarbons and also they're alkanes. So now what we know for the option A, this is explanation for option A. So since they're both alkanes and hydrocarbon, main intermolecular molecular forces formed by these compounds are London forces, or you can call it van der Waals force or London dispersion force. So they're both the same meaning. So London forces. So these are the weak intermolecular forces that are formed within the nonpolar molecules. As we know that these are hydrocarbons, it only has carbons and hydrogens. So these forms only London force interaction since they're nonpolar molecules. Okay, so they form London forces. And since we know that 2,2-dimethyl is highly branched molecule, so it has very small surface area. So what do I mean by that? I'm going to draw the structure here real quick. CH3 or here CH3, then and then I have the other compounds, the same molecule, the same compound as this one. Okay, so here it can barely form like only 2 points of contact because it's highly branched molecule. But now if you compare it with the pentane, the interaction formed between them. So pentane, I'm going to quickly draw the skeletal diagram so that it's more shortcut and easier. And also it's highly useful for IMAT exam since the time is very challenging and it's only 90 minutes. So you have to solve it very quick. So these are the structure of pentane, the skeletal structure. So these are the like interaction formed. So these are London forces, London forces. So now we can clearly see that these are only 2 contacts formed, but here we can see that there are around 5 contacts. So now why is that? Because the pentane has larger surface area, so it has more points of contact so that it can form more number of London forces with the other pentane molecules. But whereas this 2,2-dimethylpropane, since it's highly branched molecule, it can only form very limited contacts with other 2,2-dimethylpropane. So that's why the boiling point for this 2,2-dimethylpropane is very less compared to the pentane since it has very limited contact with the molecules, and so it's easier to break the bonds. So less amount of energy is needed for less number of contacts to break, but whereas for the pentane, there's more number of contact forces, more number of London force of interaction, so more energy is needed to break these bonds. So that's why pentane has greater boiling point. So now moving on to option B. So the molecule have different relative atomic mass. We can straight out say it's no, since we know it's C₅H₁₂, so both share the same molecular formula. So option C, isomer have different chemical properties. Okay, so generally we know this is true, but they've said the boiling points. We're talking about the boiling point. This is the physical property, not the chemical property. So that's why we can also directly rule this out. The option C is wrong. So now moving on to option D. Pentane has permanent dipoles. As we clearly said, they're both non-polar molecule. The only forces they form is London forces. Okay, so this is also incorrect because permanent dipoles are formed only in polar molecules. These are hydrocarbons and they're non-polar molecules. So there's no permanent dipoles. And now option E. The longer chain, less branched molecule have stronger spontaneous induced dipole. So this is correct. So they mentioned spontaneous induced dipole. This is also another word for the London forces. Okay, so both are different word with the same meaning. So this is the only correct option as we discussed. Then 2,2-dimethylpropane is branched molecule. It has limited contacts and surface area, so it has less number of contacts, so less energy needed to break these few number of contacts, whereas for pentane it's more linear. It forms more number of contacts, so thus it has more boiling point. So this option E is correct only. So that's how we solve this question. So thank you guys for watching my video. I hope you find it helpful. Please leave a like and subscribe to my channel. Thank you guys. Bye.